Welcome, engineers, to 3.1.5, Part 1, which I am calling variables. 3.1.5 itself is both variables and functions, but today I'm going to talk specifically about a variable. Like, what is a variable inside of coding? How can it help you? What is it good for? That's the idea. And just like a variable inside of a mathematical expression, like 5x plus 4 equals 10, you can solve for x. That x represents a number. So what we're going to do today is I'm going to use a variable inside of a computer code to show you how that sort of can help you design different objects. Let's get started. So I'm going to open up Robot C, show you a couple quick shortcuts just in case you've forgotten them in doing yours. So when you go to do a new code, make sure that you open up your template. And remember, when you go to do your motor and sensor setup, remember that there's the standard model. And now you'll notice that all my motors and everything have been named, and they have the right names with capital letters and things like that. Okay, so here's my code. What I'm going to do is I made a variable. It's called button press. And you'll notice I did this before the task main. You can do this, and I highly suggest that when you make your variables, you make them, these are called global variables. A variable that can be used everywhere. And you'll understand what that means when I talk about functions in part 2. But I could also do this inside the task main. I could do this button press. I could put this down here inside the task main. And then it would only work while I'm inside the task main function. But we'll get to that in a moment. So this is called, I'm declaring my variable, and I'm declaring it as an integer. There are different types of variables. You can make a character. You can make Boolean, true, false things. You can make decimals. You can make strings with letters and stuff like that. But with a variable, if you want it to be a number, that's 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, no decimals, it's an integer, int. So I've declared this as an integer. I've named it button press, and I've initialized it, so I set the initial value equal to 0. So this is going to loop forever inside of here. Let's try it out. So I'm going to hit F5. Don't know if you can see it, but you might be able to hear it. What I'm going to do, it's really cool. If you go over here and you make sure in your robot and you do your debugger windows, if you have your variables, your global variables and your local variables. If I made my variable inside the task main, it's going to be a local variable. If I make it global, if I make it outside the task main, it's global. And I have better luck with my variables showing up if I make them outside the task main. So make sure these two are highlighted. And then when you hit your start button, I'm going to go down here to variables, and you'll see my variable button press is there. Now I'm going to push my button. I don't know if you guys can see all this here. I'm going to push my button and watch what happens to the variable. See how it went up by 10? I'm going to push the button again. Ooh, my motor started running. And it went up by another 10. and then it went backwards. After it went past the maximum, it started to go backwards. So I don't know exactly. There's a glitch in the system. Remember, the biggest number you can put is 120, so I don't know what's going on there. But let's talk about variables. So what I did, I used a variable here called bump switch, and every time it was pressed, I added 10 to it. If I wanted to make this accelerate faster, I could add 20 to it every time it pushed. If I wanted it to be a little bit more sensitive, I would put in like maybe 5 or even 1, so I'd have to push it 120 times to get it all the way up to full power. But this is the like one of the applications of a variable. Let's go through kind of the formalized presentation of this. Variables and functions. So a variable is a space in your robot's memory where data can be stored. Whole numbers, we talked about integers, decimal numbers, and words. They improve the readability. And you notice that I pushed it, I named my variable button press. So when someone looks at my code, they're like, oh, that's a variable for when they press the button. So they expand the readability, meaning the ease of someone that looks at your code to know what's going on. So here's a variable called cleared. And so you can see right now when you clear the encoder and when you set the encoder value equal to 0, it's very easy to read this and say, oh, it's cleared. So readability. Creating a variable, int, this is an integer, a float. You could put float and that would be a decimal. Starts with a letter. Letters, numbers, and underscores are okay, but you can't make it like start motor. The reserved words, the words that we use in our natural while. You can't make a variable called while because that's a reserved word inside of our programming language. These are the different types: integers, float, Boolean, true or false things, characters or strings. Within principles of engineering, we probably won't use characters or strings. We most likely won't use floating. We're going to use integers and Boolean most of the time, and you'll see where and how and why. Creating a variable, you have to initialize it and you have to declare it. And you can do these both at the same time. Like you saw me, I could do them separate. I could do int speed, so I'm going to make a variable called speed, and then I'm going to set it equal to 0. Or you could do it all in one line. I'm going to declare my variable and I'm going to initialize it to 0 all in one line, which you saw me do in my code before. You can store it, and you saw what I did. Now check this out. They put a -1 times the variable, so that's going to make it opposite. So if you want to oscillate your motor, maybe every time you hit the button, multiply by -10. So then it goes negative number, positive number, negative number, positive number. So you can oscillate that and increase its speed. And you don't have to do it adding. You can multiply, you can add functions, so you can make this have some sort of acceleration curve, deceleration curve. I was just adding. I could have multiplied by 1/5 or taken it squared, like ax squared plus bx plus c. You can do all sorts of cool stuff, merging what you understand with math now into your coding. So an assignment. Now you'll notice, I don't know if you did notice this, but I only used a single equals. Remember when I was checking inside of my code if sensor value equal? I'm checking right here. This is like a question. Is it equal to 0? If you have a single equals sign, that is a declaration. That is saying set it equal to 0. So is it question mark? It is. Put it equal to that. So that's the difference between a single equals and a double equals inside of Robot C. You're declaring. A single equal is an assignment. When you go to make your variable, you set it what it's going to be on the right. So if I wanted to, remember how I did button press equals button press plus 1? You have to do that on the right. You can't go speed divided by 2 equals speed. You have to make it read from the right to the left. What you want it to be has to go on the right-hand side. What it was is going on the left. Here are some of the different things that we can do with variables. We can repeat code a number of times. You can count a user's button press, and you saw me do that. You can remember if a user ever pushed a button, or you can remember a maximum value, or you can use it to help debug your code. Let's go through some examples of how you would do this. how would you do a loop 10 times? Instead of writing a code, just cutting and pasting code 10 times, you could make a variable that it only repeats a certain number of times. So here we're doing a variable called count. So they've made a variable called count, and they set it equal to 0, and then they're doing while count is less than 5. So you can do whatever you want right here. You can start a motor, you could do anything, but then when you get into this loop, you'll have to add count equals count plus 1. So then when you get through what you do, you go back, it checks to see if it's going to do this. Now this is tricky because this is going to run 5 times. So because you started at 0 and you go 0, and then you go through it and you do 1, and you do 2, and then you do 3, and then you do 4, and then when it gets to 5, this is not less than, and it's going to kick out of that loop. So making it equal to, if you started it at 1, then you want to make sure that count is less than or equal to 5. So this is where that less than and less than or equal to, if you want to make it work a certain number of times. You could count the number of times the user does something. How many times do they push the increased volume? You maybe you've seen this on your phone, where if you increase the volume a certain amount, a warning says you shouldn't be listening to music at high levels for, right? That's exactly how they code something like this. If you push the up button so many times, hey, send them a warning. Here's an example where you count the user's actions, and I think that I did that. You saw me do it in my example. While the limit switch is not being pushed, if you then push the bump switch, that wait function is really important. You're waiting for the bounce. Like if you don't put the bounce in there, I did that on mine. My variable went skyrocketed. It was at 3,000. I pushed it once and it was already up to 3,000. Remember, if an event ever happened, well, you can use what's called a flag. If you throw a flag, you can tell. So here's an example. We're going to create a variable called touched, and bool means it's true or false. So they made it false to begin with. So they're going to run this code right here for 5 seconds. So for 5 seconds, if you push the bump switch, then you turn it to true. So then, no matter what's happening, when this program is all over, you can check the value of touched to see if it was true, to see if something ever happened. Like an example of this code would be, maybe you want to know if a door was ever opened. Like, let's say I manage a bunch of janitors, and I want to make sure they're cleaning all the rooms. So you could put like a switch on every door, and if you can't clean a room unless you open the door. So every time a door is open, it flips that switch. And so you could check to see which rooms have been cleared. Maybe you could have this populate a list online. So you have a team of janitors working together. So every time they go in, it just automatically populates this map. And you could tell whether or not someone has been in there or not through this true value. Remember a maximum value. So here's the task. Observe a sensor for 5 seconds. And then remember what the biggest number was. So here we're going to make a variable, and remember, you name it something appropriate, like they're calling it the word most. So we're going to call them most, and we're going to set it equal to 0, and then we're going to clear our timer. So we're going to run this code for 5 seconds while the timer is less than 5. So if they're using their potentiometer and they've called it knob, if that value is bigger than most, then set the variable most equal to whatever the sensor value is. So it's kind of like a ratchet system. Like if you go back down, okay, it's not, then it's not going to reassign this variable. So as this thing gets higher and higher, you're adding more to it. And so you can see what the highest temperature, the highest rating, or the highest volume was. Remember what has executed. Sometimes when you get your code, it's hard to know what has happened. So you can set flags. So like when this program is running, when I can look at variables at the end to see which part of my code has actually happened. And this doesn't look like much. So you can see the light sensor. So you're setting a variable B, and if it gets really dim, then B equals 2. Otherwise, if it's really, really just depending upon what the values were, you can set b equal to numbers, you can set a equal to numbers, and you can tell what has happened based on at the end, what do these letters look like? What do they do? What are they? And you can tell what happened in the code. Debug a program. So you can use your variables. And we talked about global and local variables. Debugging a program is just kind of what I talked about when you can set flags to see where they go and what happens. Global versus local. I like to only use global variables because I feel like they work the best in our debugger. Just make sure that so this one right here, this is a local variable because see how it's inside the task main? This one's a global variable because this rotations it's outside the task main. And here you're getting a little preview of what are called functions. See how there's the task main function right here? And now they made what's called another function forward back. We're going to get to that in the next video, but suffice to say, this is a global variable. Here's your task main. If you make it outside the task main, that means it's going to be a global variable. All right, friends, that's everything I've got for you right now. Next video is going to be functions, how to do something. If you're going to do something a lot, like multiple times, remember we had talked about that claw function, like the claw goes down, the claw grabs, the claw comes back up. That's something you're going to do all the time with maybe you just want to make a separate whole function that move your thing and then call up that function when you need it. So, till next time.